Good afternoon. Welcome to the monthly Connexus webinar series. Today we are talking about web payments aspirations and are very excited to have the W3C, or the World Wide Web Consortium, Web Payments Activity Lead, which is Ian Jacobs. So Ian, welcome. And along with us today are a few other folks that I'll introduce in just a minute. Our agenda today, I'll talk through a few housekeeping items, and we'll talk a little bit more about Ian and his role at W3C, talk a little bit about Connexus, we'll go through the presentation, and then we'll have questions and answers at the end. Just wanted to remind everybody that the webinar is being recorded. It'll be made available in approximately 15 days. You can subscribe to the Connexus online subscription in YouTube if you want to stay in touch with all of our monthly webinars. You can go to our website at connexus.org, and under resources, there's a webinar tab there where you can get the link to the videos on YouTube. There's a survey link that will be sent to you via email upon the conclusion of the webinar today. And there's just a couple of questions, literally only like 3 or 4 questions. And if you complete the survey, then you will receive a link to the slide deck. We ask that you ask the questions using the GoToWebinar interface panel, and please no vendor-specific questions. If you have any concerns or recommendations for future webinars, actually that's one of our survey questions, please contact us at info@connexus.org. So we want to thank Ali Russell, who is our Connexus host today. And my name is Cara Gunderson. I'm one of your moderators today. I'm the chair of the Data Security Standards Committee. And I'm also by day the point of sale manager at Citgo Petroleum. The other moderator with us today is David Izell with Connexus. He is the director of new initiatives. And then specifically, we have Ian Jacobs, the web payments activity lead at W3C.
And I should take a moment, this is David, to introduce Ian. I'll make it clear on your behalf, Ian, that his name is actually Ian. And
my apologies. Thank you.
No, he's famous around the W3C. He's been there longer than I have. I've represented Connexus and NACS at W3C since 1999. And so I've known Ian just about since the moment I got there. He's been at W3C since 1997, helping carry the web to its full potential. He'll explain a bit about the WC. He was editor of a number of important specs, including HTML 4.0, as part of his early life there. He was then head of communications. I think you'll see that Ian is a very good communicator. And as of February 1st in 2015, Ian took the lead of the payment standards at W3C. Thank you, Ian, for joining us to do this, and I'll turn it over to you.
Thank you, everybody, for having me. Thank you, David, for that nice introduction. It has been a long time at W3C with both of us. So to become the presenter, there we go. Let's do that. And now I'm going to show this window. 1 second. Window. Full screen mode. Okay. Can everybody hear me, and can people see web payments aspirations?
Yes.
Great. Well, thank you for having me. It's really great to be here. I look forward to hearing from you. Also, questions are very welcome. I, as David mentioned, am now the head of W3C's payments activities, and we'll explain what that means. W3C is not a long-standing player in the payments industry, but lately we've been building a nice community around ways to improve security and usability of web checkout. So what I think is really helpful to frame all of this discussion is to sort of talk about W3C's vision for the web. So web standards, David mentioned HTML. Many of the hundreds of web standards that W3C has worked on are really part of our vision of making a useful web that's available to everyone. And what that means really is creating a platform for software distribution in many ways that sort of competes with other software distribution platforms like mobile platforms. And so our project over the last, I would say, at least decade has been to sort of make the web really a great platform so that merchants and their customers and other people using the web can reach and connect with other people. So the web has to be useful in order for people to want to use it. And we got started in payments because developers were sort of turning to native mobile applications because the web didn't have good enough payments mechanisms built in. So we are trying to build this great web platform, and the standards, one useful way, at least for the purposes of this call, to think about what a web standard means is it enables some sort of capability in your browser. And so if your browser today is capable of rendering images, it's because there's some standards that enable any browser to pick up a file and render it on the screen. And of course, features have become increasingly sophisticated over time to include real-time audio and video and geolocation information, access to the device capabilities like the microphone or the camera. And so we're trying to keep up with web capabilities in browsers so that users can have great experiences and people can write code once and have it run in any browser. So think standards amount to, again, for today's conversation, browser capabilities. So W3C has been doing this for now 25 years, and we have more than 10,000 people participating in the extended W3C environment. And as I said, the vision is sort of to create a web that enables people to reach their customers. And so on the left of this slide, you see the native Facebook app, and on the right side, the web app. So the phrase web app means, in this case, it's an app that runs on the phone, but it's built using web technologies. And so that is, one aspect of the work that we've done since smartphones have appeared is to make the web scale to mobile experiences as well. So you might ask, well, why do I need the web, especially on mobile, when I can use Android apps and iOS apps, and those are very popular. So just to sort of drive home the ongoing value of the web to reach your customers, here Comscore points out that mobile web audiences, so this means accessing a website through a browser on a mobile phone, those audiences are almost 3 times the size as app audiences and are growing twice as fast. So there are significant audiences that are using the browser on their phone for certain types of activities. And the whereas everybody has a browser on his or her phone, only a small number of apps get a lot of attention. And again, according to Comscore, during this period of time that's represented in this graphic, more than half of users don't download new apps. So trying to reach your customers with apps, there are good reasons to do so, but you should also consider that it may be easier to get users to your website if your app is not one of the top apps in the App Store, just through their browser. So in order for that to be a good experience, though, the browsers running on phones but also on desktops need to have adequate capabilities, and that's where the standards come in. So a great thing about native platforms is that they showed the way in creating these great mobile experiences, and so people have become accustomed to I call it a native experience, including the ability to launch an app from a home screen, to have a sort of consistent look and feel across a mobile device. Push notifications are very important, fast performance. And so I've listed a set of native experiences, and we have for these experiences. And the challenge, of course, is that we don't control any particular operating system or platform. And so we have to do the design. It takes more time to get everybody to agree such that, if you want push notifications in a web application, it needs to work across browsers, across systems. And so it's just a little more time consuming to get all that agreement. But we have made significant progress. And today, the phrase progressive web app is used to describe a web application, it's a web page basically, that gives a native-like experience. And so here are just a few of real-world progressive web apps that from AliExpress, the Financial Times, Lyft, and Flipkart that show, at least on the one screen, you wouldn't be able to distinguish it from a native application. I don't think we're quite at parity, but we've made significant progress. And what I like to highlight is the Starbucks progressive web app. So one of the, for me, a key value of using the web is if we can achieve interoperability of web standards, you should be able to write your application once and run it across all of these different devices. So you should be able to lower your development costs, and there's a huge community of web developers out there. But beyond that sort of scalability across systems, the Starbucks progressive web app is minuscule compared to the native iOS app. And the minuscule size, translates into faster download times and faster in-place updates and so forth. But from a business perspective, and I don't have details about this, but there are links in this presentation that you'll have available to Starbucks explanations about how they doubled their daily active users once they moved into this progressive web app framework. They also point out that again, in the vision of W3C, that the web is just available on every device, their progressive web app works on desktop as well. So again, they didn't have to do two things, they just did it once, and it works on both platforms. And David had asked that I sort of make a point of, for some merchants, they might who are particularly focused on in-person experiences, why would it be useful to be thinking about these online experiences? And Starbucks answers the question. Their users use the desktop app to order ahead, and then they show up in store, and then they use the mobile app, for payment. And they pay through W3C's payment request API, which is part of the rest of the presentation. So that is, just one vendor's experience. There are lots of these that are documented on the web with very similar success stories, Tinder, Pinterest, Flipkart, and so forth, where the web application is smaller than the native one. It increases the time the users are spending online at that store. It's faster and so forth. So so this is the sort of vision currently, that we're building these experiences not just for mobile devices, but desktops and potentially other devices too, in automotive, for automotive screens and e-books, and all of this can use web technology under the hood, provided we provide a rich enough toolkit for people to develop these applications. In addition, if you are in the store, many apps are free, but those that are not, you sort of owe the store owner some money, and you don't have to do that over the web. If you're using a web application, it's linkable, can be easily discovered through search engines and social media. And so again, there's sort of distribution advantages to the web. And I don't want to sound like I'm throwing native under the bus. I think it is very healthy to have a competitive ecosystem, and all of the different parties learn from each other's successes. So there are some very web-like things now available in native apps, including like linking into the middle of an application. That's a new thing in native app land. But W3C has made a lot of progress on web, thanks to the native app showing the way. So that is the the framework is we are building a web that should run on every device with powerful capabilities, again, mostly represented through browser features. And as I said, when we got started on this work, we heard from developers that one reason they were using native was that they didn't have built-in payment capabilities into the web. And so when we started to think about what we could do to improve the web, there are lots of charts like this available, like what's causing people to abandon a checkout experience. And so here's a list. This is from Baymard, but there are others similar to this, and I don't think W3C or the web browser can help with all aspects like slow delivery, but we did feel that we could help with some friction. For example, long, complicated checkout process. If we could speed up the checkout process and sort of model one-click payments, which people like quite a bit, if we could optimize for guest checkout, that might help for many users, some of whom may not have confidence in sharing their credentials with a particular merchant. Thinking about how to improve checkout, which really hadn't changed for about 20 years, we came up with what is now called Payment Request API. So I mentioned one-click a second ago, and the idea of one-click is you reuse stored data. But if you use one-click payments on a particular merchant's site, you still have to enter the same data on the second merchant site, and so on. And so you find yourself sort of retyping this data again and again, especially painful on a small device. And so we thought, well, why don't we store it in the browser? And the browser is the common tool being used to access these sites. So today you may be a user who likes taking advantage of autofill. Autofill does speed up a certain amount of form filling, but that requires merchants to create forms, and it still requires users to sort of go through and tab through these form fields. So we thought, well, why don't we just sort of store this data in a more structured fashion in the browser, and then replace the form with an API to collect that same data. So that's the heart of Payment Request API. It is an API for merchants to very quickly collect the data that we believe to be useful for a broad range of transactions. So by building it into the browser, there's a bunch of other benefits. The browser can increase the security of the experience, because now the browser knows through a dedicated API that this is a payment scenario. The user can have a consistent user experience across the web. So instead of having every checkout experience look different, you can speed up checkout through a familiar experience. And of course, some merchants will wish to retain control over the entire journey, and that's still possible. But we think that many merchants will appreciate simply speeding up the completion of the payment. Also, by having a standard API, we think we can reduce the merchant integration costs instead of having to create a bunch of one-to-one integrations. So this is the heart of the merchant side of the story for speeding up payments. There's also a digital wallet side of the story. So if the merchant requests to be paid with this or that payment method, we also want there to be a hook in the browser so that what we call payment handlers, which are essentially digital wallets, payment handlers can register and be registered by the user to handle these payment requests. And so we'll see, I'm going to do a demo in a moment of what this all means, but it's this pair of APIs that are the core set of APIs for speeding up checkout on the web. So just to give you a sort of block diagram, the merchant calls Payment Request API, the browser shows the user some candidate payment handlers based on what the merchant accepts. The user is then going to choose one, interact with it, and when the user is done, data will go back to the merchant. And as I said, it's an API for collecting data, but now the browser is helping to speed up, simplify, and sort of harmonize that experience. So Why don't I pause before I go to demos, but a lot of it is explained through the demos, but I can check real fast to see if anybody has any questions so far. Okay, so if not, yeah, go ahead.
Yep. Technical difficulties, just please ask in the question or the chat room. So please let us know. All right, please continue. Thank you.
Okay, sure, no worries. So let's go to full screen. So this is Chrome. We'll see in a minute a little bit more about how these APIs are currently deployed today. But Chrome, you know, for the last year has been shipping with payment request API support. And so we'll do a few demos just to give a flavor of you know, the consistency of experience across different payment methods. So one of the you know, this is a checkout page, and so it's obviously not a fancy checkout page. In a second, I have one sort of template from Shopify that's a little nicer. But imagine the customer has reached the buy button and chooses to make a payment. This particular merchant only accepts card payments, and previously I have stored cards in my browser. So this is not Google Pay, this is credit card data stored in Chrome. And when I push the buy button, it triggers the API, which calls this now window that is owned by Chrome. So Chrome is displaying information it got from the merchant about these strings came directly from the merchant, and the total is displayed and so forth. And then Chrome is offering me cards that I have stored in the browser. This particular transaction is a digital transaction and doesn't require shipping address, but the merchant can also ask for shipping address and user contact information, and we'll see some demos with that in a moment. But this is sort of the basic pay with a card stored in the browser. I click the buy button. Let's say I want to use the default card that's shown to me, and I click pay. And because this is this browser is not allowed per PCI rules to store the CVV, the user is required to type it. Other payment methods will not require this, but for basic card payments, it's Chrome has implemented this. And when the user is done, the web page here shows you in JSON the data that the merchant got back. So this is the same sort of data the merchant would have gotten back through a web form, but it is now part of a standardized payload. W3C's specification is called basic card, and it describes this payload that the merchant gets back. So what's nice is now the merchant knows exactly the structure of the data they're going to get back, and then they would make use of that on the back end for authorization and so forth. So the key was basically this is the flow. Call payment request API, choose something to pay with. Let's say I pick the other card, you know, enter, you know, interact with the payment handler. In this case, the browser is the payment handler, and then data goes back to the merchant. In this case, you know, different card data. So Google likes this a lot, and they basically saw an opportunity to increase the distribution of Google Pay by offering it to users who don't have an Android phone. So this is I believe a shipping payment handler from Google. So this is not an Android or I'm using a Mac. This is a web-based payment handler. So when I go to a merchant that accepts Google Pay through Payment Request API, and if I am a Google Pay user and I have the Google Pay payment handler, now when I click buy, I get the same sort of window, but now I've gone straight into Google Pay, and I happen to have already logged in, and Google Pay has my Visa. And now when I say okay, instead of seeing the basic card data, which was the PAN and so forth, this is the Google Pay payment method. So we call this data model a payment method. And so you can see the method name is Google Pay, and instead of getting a raw PAN and so forth, now there's a token. So Google Pay sends a token back to the merchant who, through their provider, will use it to get paid. So Basic Card is one payment method. Google Pay is another payment method. You can also use Apple Pay through Payment Request API, and you get back the data that corresponds to the Apple Pay payment method. And so this ecosystem that we're building allows people to bring new payment methods to the web. The data model is defined by whoever owns the payment method, and then you have payment handlers that fulfill that payment method and return data through Payment Request API. So here's another interesting example, same user experience, but a little nicer shop. So this is a Shopify mock-up where I need to sort of change my window from full screen for just a moment. How do I get out of full screen? View, exit full screen. So I can't see on the right. There we go. So so if I add a chip and tap reader to the cart and then I go to checkout, you see the we call this thing the sheet. This is the browser experience now, and this transaction requires shipping address. So the merchant is asked for a shipping address, and again, the browser in this case is storing the shipping address information. If I choose one, the merchant can then dynamically update the shipping cost. So I chose a US-based address and the shipping is 0. I'm curious if I go back and choose a UK-based address, it's still 0. So that's not all that useful, but that may be because now I have to choose the shipping address option, and now that was 20 euros, and the merchant can dynamically update the information that's shown in the sheet, and it now reflects the total plus shipping. And then this merchant accepts the Dutch payment method called Ideal, which is a credit push, I believe. And so now when I go to pay and I choose to pay with Ideal, the Ideal payment handler is launched. I hope it works. And that worked earlier today. And ordinarily in this window, the payment handler of the website that distributes the payment handler, that experience shows up and I interact with it. So while we're waiting, I may have to try this again. Well, that's a bummer. So we'll see if it comes back. But basically, when you launch a payment handler, you're now interacting with the payment handler, which is likely to do things like authenticate you and allow you to choose from different accounts and so forth. So this demo intended to show me sort of interacting with a bank account that would initiate a credit push, and then when I said okay, instead of getting back a token or a card number, the merchant would get back some receipt saying they had been paid, and then the merchant could tell me that they were going to go ahead and ship the goods. So I have apparently lost in my battle with this demo, so I'm going to kill Chrome. But let me pause there. Sorry for that last one, but let me pause there to see if there are any questions. I hope that the demos show there's a sort of user experience that you get now through Payment Request API. You choose the payment handler you're going to respond with, interact with it, and then data goes back to the merchant. That's the key message of the demos. So
I do have a couple of questions for you, Ian.
Go ahead.
And just prior to your demo, one of the questions rolled in is where is the payment information kept? Is it at the merchant or the device? And this is just before your demo, so we might go back to a previous slide.
Sure. So there's a great general question about how is data stored? And so there's a sort of multi-part answer to that. So and where is it stored and how is it stored? So in general, the browser is going to store shipping addresses and contact information. And if the browser implements itself any payment handlers for specific payment methods, then it would also store credentials for that payment method. So in the case of Chrome, Chrome implements the basic card payment method. So in addition to the sort of Chrome storing shipping address and so forth, it also stores card details and billing address, and so forth. So that's a case where all the data is stored by Chrome. If you were paying with Google Pay, then Google Pay is the one storing the payment credentials, but Chrome is still storing the shipping address and the customer contact information. And how each party stores its data is up to that party. We actually have a FAQ where I point to each browser's website where they explain how they store this information securely. So how a browser stores information securely is a little bit outside of the scope of our API work, and they all do it differently. But some might store it on the device in the secure element, some might store it in the cloud, some might use web standards like IndexedDB to store it. So there are a variety of ways to store the information, and we sort of consider it an implementation detail from our API's perspective. And then who stores it, again, will depend a little bit on whether you're pulling data from the browser or from a third-party payment handler. So I hope that answers that question.
Yep.
Okay.
We have a couple more questions here.
Go ahead. Yes.
Is there a good case for someone developing a mobile solution for the first time now to consider only doing a payment web application without the native app? And then
So,
what kind of,
yep.
I mean, and then where do you see the cost differential between the two if you were going to skip the native app?
So that's a great question. A long time ago, I looked for sort of, you know, the definitive word on the cost differential, and I couldn't find the definitive global answer on that. So it may depend on, you know, what the app is doing and so forth. I don't know that we're yet at a place where you should forego your native experience, though I hope we get there. It just in terms of, and we'll see this more in a minute, where deployment is today. So web standards sort of take a little bit of time to reach stability and full interoperability, and we're not there yet. So I wouldn't, at least today, forego it. But if we pull it off, then you may find that you know, you can start by building your web app and distribute it in stores, like just wrap it in with Cordova or whatever,
Yeah.
and then make it available through different distribution channels. But you may be able to get away with just web technology instead of native technology. But it will ultimately depend on the functionality and the you know, consistency of deployment of the web standard. Yeah.
Okay. Good information. We did have one more question that just came in, and where do you see this sitting against the EMB-CO's secure remote commerce, or the SRC that everybody's talking about?
So that is a great question, and if I were to jump ahead to the end, there's a little bit about
Okay.
that. So I'm gonna
we'll let you go ahead then.
Let's hold off, and we can zip through. If people would really like to discuss that, I'm actually quite happy to do that and spend more time there. Let me dash through some of these slides. So as I said, we are new to payments, but we've been doing web standards for a while, but we have been able to sort of build a community of stakeholders. I think the Web Payments Working Group is now the largest W3C working group, so people seem quite interested in this. But I think we need more merchant representation on an ongoing basis, and you know, there are other parts of the world that have different payment methods that are popular, and I don't know that we're representing all of those well enough. So we would still benefit from growth, but we're doing okay. We also don't work in a vacuum, and like my earliest learning from getting into payments was, of course, all the systems and entities that already exist. So we've struck up friendships with a number of organizations, and those are healthy, active conversations. People often ask, like, so does it work? Like, do you have any data that this thing that you're doing works? So I think the home run answer would be, here is the data that shows conversions went up using Payment Request API. And unfortunately, I do not have any data like that, but I do have pretty solid data from Shopify that ran a big experiment with 30 of its largest merchants, that Payment Request is faster. And so I think Shopify found roughly that sort of as fast as or maybe 30 seconds faster on average. So I think faster is good and might help with conversions, but it's not directly, I can't directly attribute conversions to the speed up. And very specifically, J.Crew in a public interview cited their use of payment request API, and again, checkout times went down 75% through payment request API. So these are early adopters. I do not have a large list of merchants who are using this today. I am aware of lots of experiments with this. And again, we have this standard is nearly done, but not quite. Deployment experience at W3C to sort of make improvements to the spec based on what real users tell us. So this early adoption feedback is really important to the quality of the spec. So where it is today, as I said, it's deployed in many major browsers. Mozilla also has some support, but they're not shipping it readily available today. But in fact, a Mozilla engineer, sorry, Firefox engineer is the lead editor of the specification. So Mozilla is quite close to this work, but we don't have a support in Firefox today. But so part one of getting it out there is, as I said, these are about browser capabilities. Browsers need to implement the APIs, but then merchants or their service providers need to call the APIs. And so it's also valuable to see Stripe, Braintree, and others are now providing their merchants with access to payment request API. And so like some building blocks are in place for us to begin to see deployment. Airbnb is in the Web Payments Working Group, and just at the end of last month, they said, we're starting to work on, our mobile experience through payment request API. We have a few questions. So they're in the group, and they, we've had some interesting discussions about their experience. And I hope to continue to be able to report on merchants that are experimenting and what their findings are. But as I said, we've stabilized the feature set for version 1. We have begun discussions of features for the next version. So if people who are interested in that, I welcome you to join the conversation. Payment handler is not as far along as payment request. So payment handler is where the payment handlers plug into the browser. So Chrome is shipping this today, and we saw the Google Pay payment handler. Edge is looking at this closely. Samsung has indicated they plan to support web-based payment handlers. Mozilla has also said they're very interested in web-based payment handlers, but since their payment request implementation is not there yet, I haven't listed them. And there are, again, lots of experiments underway. I listed some that I know of from various banks and Facebook and Klarna and some PSPs like WorldPay. And so people are, and also PayPal, and so people are trying to get a sense of whether they can create a better user experience using this API. And so that is where we are right now. You can play with it because it's shipping in Chrome, and people are trying to figure out how to make it really work for them. I think where I see an obstacle today is I haven't listed Apple here or Safari. So today you can use payment request API in Safari, and Safari users can use Apple Pay through payment request API, but Safari users cannot get at other payment methods other than Apple Pay. And so part of my job is to continue to get a more open ecosystem for payment method support. Chrome is open. You can create a payment method and you can ship a payment handler, and it'll just work in Chrome. And we don't have the same support on Safari yet. So that's part of the group's ongoing work, is to get, as I said, interoperability and common behavior across browsers. So that's the work of the Web Payments Working Group. I can spend a little bit of time if people are interested on, because I know strong customer authentication is important under PSD2 and in other places. And I could talk a little bit about our collaboration with the FIDO Alliance on the FIDO2 stack, and W3C is part of that, which is called web authentication. So if you think I should spend a little time there, I'm happy to zip through that, or we can get to SRC if that is directly, if that is more interesting to people. Any sense?
I think you should. I think you should outline what we're doing with FIDO, and maybe not spend too much time. Just leave enough for SRC.
Okay, great. So another piece is web authentication. As I said, sort of is part of the FIDO work on FIDO2. But the motivation is that there's increasing regulatory pressure for two-factor strong customer authentication, and as we say, passwords suck. So we would like to have both stronger authentication and also more usable authentication on the web. There are lots of flaws with passwords. Sites are constantly being hacked, and people reuse their passwords, again and again across sites, so that those lead to replay attacks, and people have to remember them. So all sorts of reasons to not like passwords. So the vision of FIDO2 is that you basically have hardware-based strong authentication, and instead of, banks, I believe, have done a lot of this work with, one-time password generators, but each time you would go to the bank and get one of these key rings, that generated a password, it was sort of per bank. And so rather than have a big keychain with 19 authenticators on it, there's now a standard. And so you can bring your authenticator, to all the new interactions or relationships you have over the web. And so the FIDO standards enable you to reuse your authenticator. So an authenticator can be built into a device. So you might, like Android has built-in biometric authentication through the thumbprint reader, and that is FIDO compliant. There are fingerprint readers built into Lenovo laptops. These are all FIDO authenticators. And so when a merchant says, please authenticate the customer, instead of asking for a username and password, they basically say, please have the user authenticate using the same authenticator they used when they enrolled their relationship with me. And so now you sort of have these great streamlined experiences where you just sort of touch the fingerprint sensor or do facial recognition and so forth. So you can also, have authenticators that are external to a device or plug into a device, and there are a variety of use cases for these as well. And so basically, you can get sort of single gesture two-factor authentication. That's the home run. So in a payment flow, for example, you might say, I wish to pay with, let's say, Google Pay, and you open up the Google Pay payment handler, which then prompts you to touch the biometric sensor, and you have basically in one gesture done a two-factor authentication back to the site. So I have listed some of the advantages of using web authentication. Web authentication was used in practice within Google for a 2-year study, and there are all sorts of good findings, including cost reductions, zero authentication failures, faster authentications, and so forth. And we finished version 1 of the specification earlier this year. And now the question, as always, is how well is it deployed? So web authentication, this is the latest info. I attribute this to Adam Powers. Nice work. He's now at Amazon. This gives you the sort of state of deployment. The web authentication API is, shipping in Chrome for desktop and Firefox for desktop and Edge for desktop and Chrome, Android, and under development for Safari on desktop. So, it'll be a big home run. We hope to see web authentication shipping in Safari on mobile phones, and then you'll have really broad interoperability. But you also see in here, there are different ways that authenticators can talk to the system. They're either built in, like the Windows 10 authenticator built into the Lenovo machine, or through Bluetooth, NFC, USB. So again, you sort of see not quite universal support for all the different device APIs, but that is the project. So that you could basically use any authenticator with any device and any site. That's the goal. But this is still pretty fresh, and we're doing pretty well. So that's web authentication. I do have a demo, but basically, I think we can jump ahead. I just wanted to make sure people were aware of this. So as I said, Payment Request API and Payment Handler API are pipes through which data flow, and they're built to be agnostic to different payment methods so that people can bring new payment methods to the web. And the card brands and EMVCo are quite keen on improving card payment security through a set of technologies. We had begun discussions with them about a year ago on tokenization and 3D Secure. Then they sort of went off and came back a few months later and said, actually, we'd like to sort of frame this whole thing under the SRC umbrella. So immediately the question became, wait a minute, the SRC sort of customer journey sounds a lot like the payment request journey. Are these things complementary or in competition? And through the discussions since last fall with the card brands, our conclusion is they're very much complementary. So I have, it's not, it may not be linked from the deck, but this wiki is, but we have some flow diagrams. So for several months, we basically said, what does it mean? I don't want to force anybody to read these flow diagrams, but this was the work that we did that led us to the conclusion that Payment Request API could be a very good way to achieve the SRC vision. And so we sort of mapped SRC messages and flows to the Payment Request API flow, and these flow diagrams sort of represent what we came up with. And so then after having done that work, I say here in the slides, MasterCard, and actually independently Visa, but we ended up only seeing MasterCard's demo of doing SRC through Payment Request API at our April face-to-face meeting. And so I wrote a blog post about that and showed screenshots that MasterCard shared with us, basically showing this very mundane experience where you push the buy button like we did earlier in the demo. The payment handler that does SRC popped up, lets you choose a card, and when you choose your card, it sort of triggered a back-end communication with a token service provider, and instead of getting the Google Pay payload or the basic card payload, the merchant got back the SRC payload. So obviously the EMVCo specs are going to define the input and output data for SRC, but Payment Request API will be the sort of user experience and pipe for getting that data back to the merchant. So that's the high-level relationship between SRC and Payment Request API. And what's linked here from the deck is actually the our beginnings of a description. This is all public, so you can go check this out. This is the beginning of our description of what it would mean to do SRC through Payment Request API. And a big focus of it is the data model. What does the merchant need to provide in order to get paid? And what does the payment handler provide back for authorization? But in addition to just sort of the data model, we are talking about user experience topics as well. So we're trying to make, Payment Request API useful across a broad range of payment methods. So we have an active SRC discussion, but as I said in the deck, there's also interest from NACHA in being able to do ACH through Payment Request API. The Clearinghouse is doing some work on real-time payments. We've had some discussions with them there in the group as well. And Coil, a spin-off from Ripple, is quite interested in sort of a further afield topic of looking at alternative monetization strategies on the web, advertising and subscription being two important models today. But if you could sort of pull off micropayments, you might be able to enable sites to be paid directly. And Coil is quite interested in standards that would allow basically any site to request to receive micropayments for the user's use of their content, and that it would be standardized so a variety of parties in the ecosystem could provide services to users to help provide those micropayments. So that's a topic I expect that we will dive into in more detail at our next face-to-face meeting, which takes place in Japan in September. So again, our working group is sort of about the core APIs and what they enable in browsers, and then how different people in the payments ecosystem want to leverage them for their payment methods. To help with ensuring interoperability among this sort of growing set of technologies, we have, with EMVCo and FIDO, just recently launched what we call an interest group. So this is a discussion forum among the three organizations and their members to sort of develop a shared vision for what it means to increase payment security on the web, and also to help ensure that our specs actually work well together, don't compete with one another or conflict with one another, and to identify gaps in the specifications where, by working together, we could sort of continue to improve payments on the web. So that group just launched in May. The call I was on right before the webinar was with that group, and talking about SRC and device identification and so on. So that group will also meet in Japan in September. And then to wrap up, we have a big FAQ about this work, some links to demos and intros. People who want to experiment have said, how do I do that? So I have a little deck that says, here's how you could play with a pilot. But mostly, if you have questions or want more information, do not hesitate to contact me. And I would love to hear about your interest in the web payments. So with that, I hope we have a few more questions, and thank you for this opportunity.
And that was great, thank you. Lots of information, and you were able to capture it all in a very short time period, so we appreciate that. So just wanted to remind everybody that please use your GoToWebinar panel and type in your questions. And while they're busy typing questions, we did have another one that came up, and it was around cybersecurity. So can you talk about the cybersecurity assurance reviews and maybe the penetration tests by Web Payments Working Group to validate the cybersecurity posture for this new approach to mobile payments? And how do you know that it's trustworthy and, for lack of a better term, seaworthy?
So I don't have a good answer for that. And the reason is that the W3C sort of focuses on the development of the standards. I did mention in passing that before we finalize something as a standard, we get a lot of implementation experience. And so much of the security, privacy, and other testing is done by the companies that are implementing the standards. And they bring back from their own expertise feedback on the specification to make sure we're not creating significant issues. At the same time, W3C has standing bodies. We have a privacy interest group and a security interest group, and we have a technical architecture group as well as other topics like accessibility and internationalization. And so we do endeavor to get reviews by these groups as we go to help make sure that we're not creating obvious problems. So that's another way in which we try to help ensure that we're improving and not harming security. But I think ultimately it comes down to the expertise within each company that's implementing. So that's where we rely the most heavily.
Got it. Thank you.
Mm-hmm.
Well, there are no further questions today. And David, did you have anything to add?
No, I think that's a great presentation. I think it covered it really well. People will probably go home and think about this presentation. I know they're going to, at least sometime in the next 6 months, with regard to applications like remote ordering into stores, they're going to there's going to probably be a good cost incentive to use the Pay Request API as opposed to taking the deep dive on a native app. So I think this is extremely timely information, and thank you again for doing this for us.
Yep. Thanks everybody. And again, please look for the survey link or the survey email, and then you will receive a link to the presentation upon your completion of the survey. Or else you can check back in about 30 days when it's posted on YouTube or on the Connexus.org website. So thank you very much, everybody, and have a great rest of your day.
Thank you.
Thank you.